Today we're studying similar figures. We know that two polygons are congruent if they have the same shape and same size. Well, two figures or two polygons are going to be similar if they have the same shape and different sizes, and specifically the sides are going to be in proportion to one another. We can see here that 4 times 2 equals 8, and that 1.5 times 2 equals 3. So the fact that each side of our little polygon can be multiplied by the same thing to get the corresponding lengths of the larger polygon lets us know that these two polygons are indeed similar. Now there's a couple ways we can look at this. We can look at this as the 4 times 2 equaling 8 and the 1.5 times 2 equaling 3, so that we're multiplying by the same number for all of our sides of the little figure to get the big figure. Another way to look at it is with a proportion where we say 8 is to 4, so this big side is to the big side on our smaller figure, as 3 is to 1.5. So the top numbers in our proportion go with our big figure, and the bottom number, the denominators, go with our little figure. If we cross multiply 8 times 1.5 and 4 times 3, we end up with 12 equaling 12. So therefore we know that these two figures are proportionate. We know that when we have two fractions, we can prove they're equal to each other by cross multiplying, and if we get the same number, then they are indeed equal. So we're basically saying that 8 divided by 4 is the same thing as 3 divided by 1.5. So 8 divided by 4 is 2, and 3 divided by 1.5 is 2. So we actually have 3 different ways to show mathematically that the sides are in proportion. We're going to think about this a little more by looking at the next picture. Here we have triangle ABC and triangle DEF. In triangle ABC, that's our bigger triangle. Triangle DEF is our smaller triangle. We can see that angle A is congruent to angle D, angle C is congruent to angle F, and angle B is congruent to angle E according to the drawing. Well, side AB in our big triangle corresponds with side DE. And so 18 is the length of side AB, and 12 is the length of side DE. So we can create this ratio 18 to 12, which simplifies to 3/2. Then we can look up at our triangles and notice that side BC corresponds to side EF. The length of side BC is 12, the length of side EF is 8, and that simplifies to 3/2 as well. Then we can look at our last two pairs of sides, side CA and side FD, and we'll notice that CA is 15, FD has a length of 12, and that simplifies to 3/2. Because all 3 pairs of sides simplify to equal the same thing, we can say that the corresponding sides are in proportion. They have the same ratio. So AB is to DE as BC is to EF as CA is to FD, or all 3 of those ratios are equal to each other. Therefore, the sides are in proportion, and these are similar triangles. As long as the corresponding angles are congruent, that means the angles that go on top of each other, if you were to line these two figures up, as long as the corresponding angles are congruent to each other, and as long as the corresponding sides are in proportion to one another, you have similar figures. And this is called a similarity statement. Here we see the symbol that looks like a squiggly, and that means similar. So this is read, triangle ABC is similar to triangle DEF. So one thing that's really important to keep in mind is that the notation is very specific. So this lets us know that because of the order the letters are written in, angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. In addition, side AB is corresponding to side DE. They're not congruent, but they're corresponding. That means they line up together. Side BC corresponds with side EF, and side AC corresponds to side DF. In this example, we have triangle RUN similar to triangle TSM. We can use the letters in our similarity statement to figure out which angles are congruent to each other. Angle R is going to be congruent to angle T. Angle U is going to be congruent to angle S. And angle N is going to be congruent to angle M by the way they line up. So we now also know that side RU corresponds with TS, UN corresponds with SM, and RN corresponds with TM. So I want to figure out what the length of side RU and what the length of side MT are. So I have two proportions to solve, one for each of those variables. So the first thing I'm going to do is find corresponding sides where I know what the lengths are. For example, in this case, UN is 15, and it corresponds with SM, which is 24. So I'm going to write UM over SM, UN over SM. And we're going to be solving for X, so I'm going to write UR, since that's the length of UR. And we know that UR corresponds with ST, so I'm going to write ST underneath that. So now I'm going to replace everything with what belongs in its place. So UN is 15, SM is 24, UR is X, and ST is 40. Now I just have a proportion that I can solve. So I can cross multiply and solve. 24 times X is 24X. 15 times 40 is 600. I can divide both sides by 24 in order to solve this one-step multiplication equation, and X equals 25. So now I know that X is 25. Now we're going to use the same process in determining the length of Y. We're going to start with the two sides that correspond with each other that we were given. We don't want to work with X, because if we solved X incorrectly and we try to use that to solve Y, then we're going to get the wrong answer for Y. So I'm going to go back and start with the same ratio I started with, UN to SM. So UN and SM, I knew the lengths of those. I'm going to set those equal to RN over TM. Now, one thing I want to mention, and that I always do, is I keep in mind in my proportions that I'm using either big triangles in the top and little triangles in the bottom, or vice versa. In this case, UN and RU were both from the little triangle. So my sides from the little triangle are in my numerator. SM and TS are coming from my big triangle, so the denominator has sides from the big triangle. I'm going to label this so that I don't make any careless mistakes, because if I accidentally put big in the numerator for one ratio and little in the numerator for the other ratio, then my whole problem is wrong. So I'm going to go back to this ratio, UN over SM equals RN over TM, and replace all of these sides with their lengths. So UN is 15, SM is 24. And then RN is 35. So we write in 35. And TM is Y. So again, keep in mind we have our little triangle on the top, big triangle on the bottom. You can do it the other way around. You can have the big in the top and the little in the bottom. It really doesn't matter. Now I'm going to cross multiply. 15 times Y is 15Y. 24 times 35 is 840. I'm going to solve this equation by dividing both sides by 15, and X is 56. We're going to move on now and look at a word problem. This is a very classic word problem. It says, at the same time, a tree on level ground casts a shadow 48 meters long. A 2-meter pole casts a shadow 5 meters long. Find the height H of the tree. Well, this is a pretty simple one. We can see how everything lines up. So we're going to start off with EB, ED, compared to CB, those correspond, and DA compared to BA, those correspond. Now we're going to replace everything with what we know. ED is H or X, it doesn't matter what variable. CB is 2. 48 is DA, so we put 48 in the place of DA, and then 5 is BA, so we put 5 in the place of BA. Now notice I have my big triangle on the top and my little triangle on the bottom. And there's several ways to do this. I'm going to stick with explaining this particular way. There's 2 different approaches and 4 different ways you can show your steps. So now I'm going to cross multiply. 5 times H is 5H, 2 times 48 is 96. So now I'm going to divide both sides by 5, and the height is 19.2 when I divide 96 by 5 in my calculator. And I want to remember my unit, which is meters. Now I have these 2 triangles. I'm going to set this up again by looking for 2 sides that correspond where I know the lengths. And I can see automatically, since these are pretty easy to tell what sides correspond, that 8 and 10 are going to be my 2 sides to work with. So I'm going to start having MA compared to SR. In this particular example, I have my little triangle on the top and my big triangle in the denominator. So the numerator is the little triangle, the denominator is the big triangle. And I could have done it upside down, doesn't matter. And then I want to solve for x, so I'm looking at MB, and I'm putting that in the numerator since my little triangle's in the numerator, and MB corresponds with SO in that order, so SO is in the denominator. I'm going to replace all of this with the lengths, so I end up with MA is 8, SR is 10, MB is X, and SO is 12. I'm going to cross multiply and solve, and I end up with 10 times X is 10X, 8 times 12 is 96. Divide both sides by 10, and X equals 99.6. For Y, I'm going to come back, I'm going to use MA over SR again as my starting point, since those are the numbers that we know. And then I am looking for OR, and that's going to go in my denominator because that's where my big triangles are. And the side that corresponds with that is BA, so BA goes in my numerator. Now I'm going to replace all of these sides with their lengths, so I end up with 8 over 10, just like I did in the last problem, equals BA was 5, and OR is Y. So BA is 5 here, OR is Y. Now I have a proportion I can solve by cross multiplying. 8 times Y is 8Y, 10 times 5 is 50. Divide both sides by 8, and I end up with Y equaling 6.25. In this example, the triangles start to get trickier because they're flipped around, so it's really important to stop and think about which sides and angles correspond. So angle G corresponds to angle T because of the way it's written, so I'm going to show my congruency. Angle E corresponds with angle I, that's already drawn into my drawing with right angles, and angle M is congruent to itself, so I'm going to put that in